Pretty much what this asks us to do is we want to use our parent function. So the parent function here is going to be x to the third, mainly because right here it says to the third. And we're going to use that and transformations to make this work. Now, if you remember, all transformations are going to be of the form a multiplied by p x minus h plus k. Now, usually there is a b in here, but since this one doesn't have a b, we're not going to deal with that. Well, a is going to be our stretch, so our stretch is going to be 1/2. That's our vertical stretch. We're going to go, h in our case is going to be 1, and k is going to be 4. So this will tell us how much we're going to go right. This tells me how much we're going to go up. So my original function, so in other words, p of x is going to look something like this. Starts at 0, 0. Then we go over 1, up 1, because 1 cubed is 1. And then 2 cubed is 8, so that's going to go here. And then 3 cubed is 27. It's too big. I'm not going to deal with it. Negative 1 cubed is negative 1. And then we're going to go down to 8 here. So my parent function is going to look something like this. And we're going to do transformations on that. So in our new function, s of x, we're going to go right 1 and up 4. So right 1, up 4 is going to give us this spot right here. Now, instead of going over 1, up 1, I'm going to go over 1, up 1/2, mainly because my stretch is 1/2. So all my y values are going to stretch by 1/2. Then instead of going over 2, up 8, I'm going to go over 2, up 4, because half of 8 is 4. Then I usually go, when I go 3 over from my inflection point, 1, 2, 3, I usually go up 27, but half of 27 is 13. So I'm actually going to go up 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and a half. So it's going to be somewhere around here. And then we're going to do the other same thing on this side. 1, 2, 3, 4. And then we're going to go down 13 and a half. So over 3, down 13 and a half. So there's 4, 5, 6, 7, 8, 10, 11, 12, 13 and a half. So it's going to be right here. So our equation is going to look something like this. Now it wants us to find x and y intercepts. Our x-intercept is actually really easy to see since it actually hit right on there. So my x-intercept is going to be -1, 0. But if it didn't happen nicely, well, how would you find it? Algebraically, if I want an x-intercept, I need to set my function equal to 0. So I'm going to set this s of x equal to 0. And that gives me 1/2 x minus 1 cubed plus 4. Subtract 4 to both sides. You end up getting -4 equals 1/2 x minus 1 cubed. In order to undo that 1/2, I'm going to multiply both sides by 2. So I end up getting -8 equals, that goes away with that, so I get x minus 1 cubed. Undo the cube by doing the cube root. So I end up getting -2 equals x minus 1. So now x equals -1 if I add 1 to both sides. So that's how I would get x equals -1, and that's what I ended up getting here. Now, in order to find my y-intercept, which looks like it's going to be a little harder to find, we're going to set x equal to 0. So in other words, we end up getting 1/2 multiplied by 0 minus 1 cubed plus 4. Well, then we get 1/2 -1 cubed plus 4. -1 cubed is -1 plus 4. Then I end up getting negative 1 times 1/2, which is negative 1/2, plus 4, which is 8 over 2. So you end up getting negative 1/2 plus 8 halves, which is going to be 7 halves. So it's going to be, my y-intercept is going to be 0, 7 halves. And there you have it.